Differential pulse code modulation, DPCM అంటాం. It is a technique which will be similar to the PCM, and it is also be analog to digital communication. Digital signal conversion will be takes place here. Whatever the analog signal you are giving to the DPCM, that will be also be converted into the similar way to the PCM. That will be converted into the digital binary sequence, zeros and ones, whatever the signal. And we have some demerits of the PCM signal. In samples of the signal will be highly corrected. How it will be highly corrected means the differential pulse code modulation is a technique to differential code technique, and here you can see that the technique samples the analog signal, then quantize the different signal between the sample values and predicted values, and we can go for the sample signals. Here you can see 70 and 80 and 90. Both three samples will be same amplitude and same information that will be carrying 101, 101, 101. So whenever it will be obtaining the same information, then the samples will be differ here. The samples will be differ here. Okay, and the adjacent samples will be always be same. Then information is small difference will be takes place between the adjacent samples and forward samples. Then the PCM system will be encoded, and whenever it will be encoded, the resulted signal contains some redundant information bits. Here 70, 80, 90 unnai chudandi. They will be consist of same information, and they will be differ in the small variation of the encoded signal. Okay, and the above figure, which will be shows the containing of the time signal x of t, is denoted by the dotted lines. ఏదైతే మీకు dotted lines తో ఒక sinusoidal signal కనబడుతుందో, that is the input signal x of t. So that will be denoted by the dotted lines. Okay, and here whenever the signal will be sampled by flat top sampling at interval of ts, 2ts and 3ts and nts, the sample signal x of t will be sampling at the interval of the ts, 2ts and 3ts and nts. The sampling frequency will be related to the Nyquist criteria. Okay, Nyquist rate మీద బేస్ చేసుకొని sampling frequency అనేది మనం ఇక్కడ కన్సిడరేషన్ అనేది తీసుకుంటాం. These samples will be encoded by using the 3-bit PCM, BCM. Okay, the samples are quantized to the nearest digital levels. That will be seen in this diagram. Okay, ఇక్కడ ఏవైతే తీసుకుంటున్నారో మీరు samples అనేది 3-bit encoder అనేది ఇక్కడ యూజ్ చేసాం. So we will obtain the 000 and 010, 100 ఇలా information అనేది they will be sampled here. Okay, and here coming to the principle of the differential pulse code modulation. Here, if the redundancy is reduced, then the overall bit rate will be decreases. And the number of bits required for the transmit one sample will also be reduced. This type of digital pulse code modulation is called as differential pulse code modulation. అంటే ఏంటంటే redundancy అంటే మీనింగ్ అక్కడ వచ్చేసరికి ఏంటంటే సేమ్ శాంపుల్స్. ఇక్కడ ప్రీవియస్ డయాగ్రామ్ లో చూసారు కదా, 70, 80, 90, they will be obtaining the same information and same sample will be obtaining. Whenever it will be encoded, then they will be obtain the redundant bit. So whenever the redundant bit will be reduced, then automatically the overall bit rate will be decreased. So the number of bits required to transmit one sample will be reduced. Whenever automatically the redundant bit will be reduced, then the bit rate will be also be reduced. So this type of digital pulse code modulation is considered as differential pulse code modulation. Okay, so the differential pulse code modulation always depends on the prediction. Depends on the prediction principle. Okay, the value of the present sample, the value of the present sample, the value of the present sample always depends on the previous. The value of the present sample will be depends on the previous. ఏదైతే మీరు వాల్యూ అనేది తీసుకుంటున్నామో present sample అనేది previous samples మీద డిపెండ్ అయి ఉంటుంది. ఎందుకంటే always they will check whether the same sample will be obtained or not. If the same sample will be obtained, then it will be goes under the differential pulse code modulation to reduce the redundant bit. So for that, the present sample always be depends on the previous samples. Okay, predicted by from the previous samples. The predicted may not be exact. Prediction value అనేది may not be exact గా ఉండకపోవచ్చు. Very close values అనేది రావచ్చు, లేకపోతే they will be same. Okay, here the sampled, okay, the sample signal is denoted as xnt of s. Okay, sample signal అనేది x of t అని చెప్పా కదా ఇందాక, సేమ్ x of t నే మనం x of nts అనేది రిప్రజెంటేషన్ అనేది తీసుకుంటున్నాం. And the predicted signal is indicated by the x cap of nts. ఇక్కడ చూడండి, మనకి ఇది DPCM బ్లాక్ డయాగ్రామ్. DPCM బ్లాక్ డయాగ్రామ్ వచ్చేసరికి sampled signal. ఓకే, అంటే మీరు ఇస్తున్న ఇన్పుట్ సిగ్నల్, the sample will be sensor signal will be x of t, అంటే x of nts, and predicted signal means x cap of nts. ఇక్కడ చూడండి, కింద నుంచి మనం అనేది ఇస్తున్నాం. Both signal will be given to the comparator. Comparator will be compares the previous signal and present signal. అంటే present sample previous sample compare చేసి then it will be gives the error signal, whatever the error that will be obtained across the quantizer. That signal will be E of nts, and that will be given to the quantizer. That will be given to the quantizer. From the quantizer we will be obtain the whatever the exact quantizer error signal of the signal. So EQ of nts అనేది మన సిగ్నల్ అనేది తీసుకుంటాం. So here you can see that samples nts and the will be indicated as x cap of nts. Okay, the comparator finds out the difference between the actual sample signal and predicted value signal. So the signal is called as signal error. So error signal will be represented as E of nts, E of nts. Okay, and that signal E of nts will be given to the quantizer. So E of nts output వచ్చేసరికి ఏమవుతుందంటే E of nts is equal to input signal minus prediction signal. Okay, sample signal minus prediction signal. So x of nts minus x cap of nts. Okay, x cap of nts, that will be taken as a equation 1. Okay, that will be taken as a equation 1. Here the predicted value x cap of nts is produced by using the prediction filter. ఏదైతే prediction value అనేది మనం తీసుకుంటున్నామో that signal will be produced by the prediction filters. ఏవైతే prediction filters అనేది మనం యూజ్ చేస్తున్నామో సిగ్నల్ ప్రాసెసింగ్ లో, that will be obtained here. Okay, the quantized output signal, the quantized output signal E of t and the previous prediction is added and given as a input to the prediction filters. This signal will be denoted as xq of nts. This signal will be denoted as xq of nts. Okay, this makes the prediction close to the actual sampled signal. This makes the prediction close to the actual sampled signal. The quantizer error signal EQ of nts is very small and can be encoded by using the small number of bits. Okay, whatever the signal that will be obtained when our quantizer, that signal will be very small, and that small signal easily encoded by the small number of bits. Okay, that number of bits for sample is reduced by DPCM. Okay, and the quantizer output will be given as, okay, మీకు ఇక్కడ ఏదైతే ఇక్కడ సిగ్నల్ వచ్చిందో En of s అనేది signal, that signal will be given to the quantizer. And from the quantizer again it will be given to the prediction filter for the prediction purpose, previous signal అనేది మళ్ళీ ఇన్పుట్ కి తెలియాలి కాబట్టి again we can use the prediction filters for the identification of the previous signals, and that quantizer signal output will be obtained as EQ of NTS is equal to EQ of NTS is equal to E of NTS అంటే error signal plus quantized signal Q of NTS. So Q of NTS is the quantized error, and from the block diagram, the prediction filter input is XQ of NTS is obtained by sum of X cap of NTS and quantized output. Okay na, మన prediction కి input ఏమి ఇస్తున్నాం అంటే quantized output ఇస్తున్నాం, at the same time X cap of NTS అనేది input కింద ఇస్తున్నాం. So XQ of NTS value వచ్చేసరికి XQ of NTS value వచ్చేసరికి X cap of NTS plus EQ into NT of NTS, equation number 3. Okay, by substituting the value of EQ of NTS from the equation 2 in equation number 3, we can obtain that XQ of NTS is equal to X cap of NTS plus E of NTS plus Q of NTS. Okay na, మనకి ఏమందంటే quantized output వచ్చేసరికి ఏంటంటే మన prediction value plus error signal plus quantized error. So equation 4 అనేది మనకి ఆ విధంగా representation అనేది వస్తుంది. Okay, and from equation 1 we can write that E of NTS plus X cap of NTS, E of NTS plus X cap of NTS equal to X cap of NTS, equation number 5. So from the above equation 4 and 5, we can write that XQ of NTS is equal to X of NTS plus X of NTS. Okay, X of NTS plus X of NTS representation అనేది తీసుకుంటాం. So quantized version of the signal XQ of NTS is sum of the original sampled value and quantized error Q of NTS. Okay, Q of NTS. The quantized error can be positive or negative. A quantized error అనేది పాజిటివ్ ఉండొచ్చు, నెగిటివ్ ఉండొచ్చు. ఓకే, సో దట్ విల్ బి డిపెండ్స్ ఆన్ ద prediction filter. So prediction filter does not depends on the characteristics. Prediction filters will not be characteristics. Okay, and here this is the transmitting part. మీరు ఏదైతే సిగ్నల్ అనేది ఇక్కడ తీసుకుంటున్నారో ఆ సిగ్నల్ ని మనం ట్రాన్స్మిటింగ్ పార్ట్ కింద తీసుకుంటాం. ఓకే, ఇక్కడ డయాగ్రామ్ ఒకటి గుర్తుంటే చాలు, ఈక్వేషన్స్ అవే వస్తాయి. ఓకే, ఈక్వేషన్స్ అనేది అవే సబ్స్టిట్యూట్ చేస్తాం. ఇక్కడ ఎందుకు మనం డయాగ్రామ్ లోకి వెళ్తున్నాం అంటే మీకు సేమ్ adjacent side by side samples అనేది సేమ్ వచ్చినప్పుడు then you can go for the to reduce the redundant bit, అంటే సేమ్ ఉన్న samples ని reduce చేస్తే then automatically bit rate will be reduced. For that purpose you go for the DPCM. Here DPCM which will be uses the sample signals and that will be given to the quantizer. Here whenever it will be given to the quantizer, they will be compares the present sample with previous sample by using the prediction filters. Whenever it will be compared, small error will be obtained. That error signal will be E of NTS. So the error signal will be given to the quantizer. Then it will be quantize the error signal. Then we can obtain the EQ of NTS. That small signal will be given to the encoder. Then the number of bit will be also be reduced here for the encoder. This is the transmitting part of the what will be called as DPCM. This is the transmitting part of the DPCM. So coming to the differential pulse code modulation of the receiver. So in order to reconstruct the receiver digital signal, the DPCM as shown in the figure. Whenever using the encoder, then automatically you can use the receiving part decoder. And prediction filter. In the absence of the noise, the encoder's receiver input will be same as the encoder transmitter output. Okay, and here you can see that whatever the encoder signal from the DPCM, that signal will be given to the decoder, and that signal will be decodes the signal, and it will be it will be given to the some representation of the comparison. Okay, comparator. Okay, comparator will be present signal will be compared with the previous sample, then it will be gives the reconstruct the original signal of the signal. Okay, and here the prediction undertakes a value based on the previous output. Whatever the prediction filter, that always be depends on the previous output. So prediction filters ki మనం input ఏమి ఇచ్చాం అంటే అవుట్పుట్ నే మళ్ళీ తీసుకొచ్చి ఇన్పుట్ కింద ఇస్తాం. ఇన్పుట్ కింద ఇచ్చామంటే ఏంటి మీనింగ్, అక్కడ అవుట్పుట్ సిగ్నల్ ఏవైతే ఉందో అంటే ప్రీవియస్ సిగ్నల్ కింద చెప్తాం అన్నమాట అవుట్పుట్ ని. సో దట్ సిగ్నల్ విల్ బి గివెన్ టు ద ఇన్పుట్ and they will be verified by using the comparator. Okay, by using the comparator. So the input given to the decoder is proceed, and the output is summed up to the output of the predictor. So the output is summed output of the predictor. That means first of all the decoder will be reconstruct the quantized form of the original signal across by using the prediction filters, by using the prediction filter. Okay, and here therefore the receiver differs from the actual signal by quantized error, which is introduced permanently by reconstructed signal. And coming to the applications of the DPCM, only the DPCM signal, DPCM transmitter and receiver, which will be used in the speech signaling. Only it will be used in the speech signaling, and some of the image signals that will be used in the ammunition field. Okay, and we can also be used the audio or speech signals, which will be same, and only it will be used for the speech identification of the audio. Okay, and DPCM connected on the signals with the correlation between the successive samples leads to the good compression ratio. Wherever the compression technique will be used, there you can also be used the good compression ratio by using the DPCM, because it will be reduces the bit rate. Okay, and in image there is a correlation between the neighboring pixels in video signals. The correlation is between the same samples in the consecutive frames and inside frames. That means if the same pixels will be obtained whenever it will be encoding, then you can use the DPCM to reduces the redundant bits in the same samples. Okay, this method will be really useful in the real-time applications of the speech, signals. Okay, and efficiency also be very high. That will be seen in the medical compressions and real-time applications of the medical images. Okay, and it will be effective for lossless compressions and implementation of the lossless and near lossless medical images. అంటే మనం DPCM మాక్సిమం ఎక్కడ యూజ్ చేస్తామంటే స్పీచ్ సిగ్నల్స్ దగ్గర కానీ ఇమేజ్ సిగ్నల్స్ ని ఐడెంటిఫికేషన్ చేసేటప్పుడు మెడికల్ ఫీల్డ్ లో వాట్ ఎవర్ ద మెడికల్ ఫీల్డ్, any chances of pixel overlapping whenever it will be encoding, then they will be obtain the image DPCM, differential pulse code modulation, to overcome the prediction. Redundant bit అనేది రిమూవ్ చేయడానికి ఎక్కువగా యూజ్ చేస్తాం. Here redundant bits means any overlapping same value will be obtained, then it will be considered as a redundant bits will be obtained. Okay, so this is the all differential pulse code working technique. Okay, and we can see the what is the difference between pulse code modulation and differential pulse code modulation. Here pulse code modulation means it will be taken as some parameters related to the characteristics. First parameter that will be considered as number of bits. Here number of bits means taken means it uses the 4 to 8 or 16 bits for sample, 16 bits for sample, PCM. Okay, differential pulse code modulation వచ్చేసరికి ఏంటంటే always it will be choose the minimum number of bits less than the PCM bits. Okay నా, less than the PCM bits, తక్కువ బిట్స్ అనేది యూజ్ చేస్తుంది. అది కూడా ఎలా అంటే PCM కన్నా కూడా తక్కువ ఉంటుంది, ఎందుకంటే మనం reduce చేస్తున్నాం bits, number of bits ni whenever you go for the differential pulse code modulation. Okay, and levels and step size, levels and step size, fixed step size cannot varied. Okay, step size will be constant in PCM. Okay, levels only, the fixed number of levels are used, fixed number of levels are used. Okay, PCM lo use cheyaru, DPCM lo use chestam. Okay, bit redundancy present, can permanently removed, bit redundancy అనేది రిమూవ్ చేస్తున్నాం DPCM లో. ఓకే, and quantization error and destruction depends on the number of levels it will be used. Okay, and here DPCM, the slope overhead destruction and quantization noise will be present but very less compared to the PCM. PCM తో కంపేర్ చేసినప్పుడు quantization error కానీ డిస్ట్రక్షన్స్ కానీ తక్కువ ఉంటుంది. ఓకే, and the bandwidth of the transmission channel, the bandwidth of the transmission channel is very high in pulse code modulation and it is very low or very less in differential pulse code modulation. And feedback, here feedback means the circuit related characteristic, no feedback for the no feedback in transmitting and receiver, and feedback will be adjusted. Always transmitting part feedback will be obtained due to the protection filters, and receiving part also the feedback circuit will be obtained across the protection filters. Okay, and complexity, here complex circuit will be complex compared to the PCM, compared to the DPCM, and DPCM circuit is simple. And coming to the signal to noise ratio, the signal to noise ratio is good for PCM and compared to the DPCM, and DPCM the signal to noise is somewhat good. Okay, these are the differences between the PCM and DPCM. These are the difference between the PCM and PCM. అందరికీ అర్థమైందా? హలో, ఇక్కడ గుర్తుపెట్టుకోవాల్సింది ఏంటంటే, ఓకే PCM చేస్తున్నాం, అనలాగ్ సిగ్నల్ టు డిజిటల్ కమ్యూనికేషన్ చేసినప్పుడు కూడా మనకి ఏమవుతుందంటే కొన్ని సిగ్నల్స్ అనేది సేమ్ సిగ్నల్స్ వస్తాయి. అంటే అడ్జసెంట్ శాంప్లింగ్ చేసిన తర్వాత కొన్ని శాంపుల్స్ సైడ్ బై సైడ్ శాంపుల్స్ అనేవి సేమ్ వస్తాయి, కానీ యాక్చువల్గా సేమ్ ఉండవు. అక్కడ సమ్ వేరియేషన్స్ అనేది మనం చూపించాలి. సేమ్ ఉంటే ఏమవుతుందంటే దే విల్ బి గో ఫర్ ద రిడెండెంట్ బిట్స్, అంటే సేమ్ ఉన్నప్పుడు వేస్టేజ్ ఆఫ్ శాంప్లింగ్ అనేది జరుగుతుంది. అక్కడ అలా జరగకూడదు కాబట్టి యూ కెన్ రిడ్యూసెస్ ద రిడెండెంట్ బిట్, విల్ గో ఫర్ ద డిఫరెన్షియల్ పల్స్ కోడ్ మాడ్యులేషన్. డిఫరెన్షియల్ పల్స్ కోడ్ మాడ్యులేషన్ ఏం చేస్తుందంటే శాంప్లింగ్ అనేది ప్రెసెంట్ శాంపుల్ అనేది ప్రీవియస్ శాంపుల్ తో కంపారిజన్ చేసుకొని సేమ్ ఉంటే ఎర్రర్ ఏదైనా ఉంటే చెక్ చేసుకొని ఇట్ విల్ బి ట్రాన్స్మిటెడ్. సో మనకి ఎప్పుడైనా ఇక్కడ డయాగ్రామ్ చూస్తే ఇక్కడ శాంపుల్ అనేది ప్రెసెంట్ శాంపుల్ అనేది తీసుకుంటున్నాం. శాంప్లింగ్ ఇన్పుట్ అనేది ప్రీవియస్ ఇన్పుట్ వచ్చేసరికి ప్రిడిక్షన్ ఫిల్టర్ యూజ్ చేసుకొని ఫీడ్బ్యాక్ సర్క్యూట్ ద్వారా అగైన్ ప్రిడిక్షన్ వాల్యూ ఆఫ్ ది ఎక్స్ క్యాప్ ఆఫ్ సిగ్నల్ అనేది తీసుకుంటున్నాం. సో కంపారిజన్ చేసుకొని క్వాంటైజర్ సిగ్నల్ కి ఇస్తే క్వాంటైజర్ విల్ బి ఎర్రర్ సిగ్నల్ విల్ బి అబ్టైన్ బై యూజింగ్ ద క్వాంటైజర్, దట్ సిగ్నల్ విల్ బి గివెన్ టు ద ఎంకోడర్. అలా ఇవ్వటం వల్ల ఏంటంటే మనకి prediction అనేది reduce అవుతుంది. Automatically redundant bit will be also be reduces and number of bits for transmission will be reduces. So that will be advantage in the differential pulse code modulation. And similarly the receiving part signal will be decodes the signal. Again here whatever the prediction signal that will be added for the reconstructed the signal across the receiving part. So ఇక్కడ DPCM అనేది ఎక్కడ యూజ్ చేయం, ఓన్లీ ఇట్ విల్ బి యూజ్డ్ ఇన్ ద స్పీచ్ కమ్యూనికేషన్. ఎక్కడైతే స్పీచ్ సిగ్నల్స్ అనేది మనం మానిటరింగ్ చేస్తున్నామో, సేమ్ వాయిస్ ఉందో, సేమ్ సిగ్నల్ అనేది మనం ట్రాన్స్మిట్ చేస్తున్నాం లేదా, వాట్ ఎవర్ ద సిగ్నల్ దట్ విల్ బి స్పీచ్ సిగ్నల్స్ విల్ బి కమ్యూనికేటెడ్, that only you can use the DPCM. Only particularly it will be used for the speech signaling process. And also some of the image processing techniques also it will be used in the medical field. It will be used in the medical field. Here also we have drawback similar to the PCM లో ఏదైతే డ్రాబ్యాక్స్ ఉంటాయో DPCM లో కూడా సేమ్ డ్రాబ్యాక్స్ ఉన్నాయమ్మా. ఏంటంటే ఆ డ్రాబ్యాక్ వచ్చేసరికి here also circuit complexity will be high, and also high bandwidth will be used. Higher bandwidth will be used in the DPCM and PCM. Okay, that is the small drawback for the both the techniques. Okay, and we have discussed the next class another two techniques which will be related to the analog to digital communication conversion techniques, which is delta modulation and adapt to delta modulation. Tomorrow class lo rendu cheptanu, evaru miss avmakandi. Okay na? Hello.
Yes,
Today
sir.
class is ended. Okay.